Physics for everyone welcomes you. Let us learn comparison between gravitational force and electric force now. In that, first we have to learn the definition of Newton's law of gravitation and the definition of Coulomb's law of electrostatics. With this knowledge, we will be learning the similarities between gravitational force and electric force. Then we learn the dissimilarities between the gravitational force and electric force. So let us start. Newton's law of gravitation. The force of attraction between two objects is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Mathematically, we can write the gravitational force equals G times m1 m2 divided by r square. Coulomb's law of electrostatics. The force of interaction may be an attraction or a repulsion between two stationary point charges in vacuum is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Mathematically, let us write the electrical force equals K times Q1 Q2 divided by R square. Now let us learn what are all the similarities between the gravitational force and electric force and the dissimilarities between the gravitational force and electrical force. Right. So before that, the two objects, they have mass and charges. Right. The attraction between the mass comes under Newton's law of gravitation, and the force of attraction or repulsion between the charges available in the two objects comes under Coulomb's law of electrostatics. Good. So we'll go with similarities. The two forces, gravitational force and electric force, acts between objects, right? The first one between the masses of the object, the second one between the charges in the object. Good. The gravitational force directly proportional to the product of their masses, Fg proportional to m1, m2. Whereas the electrical force directly proportional to the product of their charges, Fe proportional to Q1, Q2. Both the forces, gravitational force and electrical force, inversely proportional to the square of the distance between them. The gravitational force and electric force are central forces. What is central force? The force acts along the line joining the center of the two bodies is called the center force. So gravitational force is a central force and electric force is a central force. Gravitational force and electric force are conservative force. What is the definition of conservative force? The work done against these forces does not depend on the path followed. It depends only on the initial and final position. Good. So gravitational force and electric force are conservative force. They are related with their potential energies. Dissimilarities. The gravitational force always attractive, whereas the electric force can be attractive or repulsive depending upon the nature of charge available on the objects. Like charges repulse, unlike charges attracts. The gravitational force is very, very weak unless one of the body is very large, right? We don't find any gravitational force between two balls, two small balls, but we find a gravitational force between the earth and the small ball. Good. Here, the electrical force is very, very strong, but there are equal number of electron and proton in an object. So, mostly we don't find an electrical force between two objects. Within the object, their forces are getting cancelled. The gravitational force is independent of the medium. The medium does not affect the force of attraction between two objects, whereas it is not so in the case of electrical force. The medium plays a major role in deciding the force between the electrical force between the two charges. The G, the gravitational constant, is independent of the medium. That is why it is called universal gravitational constant. Whereas the K, that in turn depends upon that's equal to 1 by 4 pi epsilon naught. That epsilon is the permittivity that decides what type of medium has been there between the two charges, right? So epsilon, that is a permittivity depending upon the medium. Good. The value of G is 6.67 into 10 power minus 11 Newton meter square kilogram power minus 2. This is very, very small compared to K. So the gravitational force is weak. The value of K is 9 into 10 power 9 Newton meter square coulomb power minus 2. This is very large compared to capital G. So the electrical force is greater, larger. Thank you, children.